All right, this is a pretty interesting screen to look at. What we see here is the battery response depending on state of charge. Now, right now we're just looking at an old, what I guess, maybe lead acid battery or whatever they have in the Cessna 172. And what we're saying is that 100% state of charge, this thing is good for 1.5 kilowatts or about 2 horsepower. Now, where did this 1.5 kilowatts come from? Why is that? Well, I got a little hint here for you at the bottom. System Electrical lists 1 batteries at 240 watt hours each for a total of 240 watt hours. That's the amount of energy. Systems Limits 2 lists nominal battery voltage of 24 volts at 60 amps for a max output of 1,470 watts per battery. And so there we go. This 1.5 kilowatts is clearly just rounding on the scale here, but we go up as high as 1.47 kilowatts. So in other words, it's the system's limits, okay? System's limits. Our battery voltage is 24 and a half, and our battery amperage is 60. You see that? 24.5 volts at 60 amps. You multiply those two together and you get 1,470 watts. And Systems Electrical 1 lists 240 watt hours each for a total of 240 watt hours. And here it is, 240 watt hours for battery. And there's 1 battery on board. One battery. So when you combine the voltage and amperage limits in the systems too, you get the wattage of the battery. When you enter the watt hours of the battery, the number of batteries, you get the total energy capacity in the airplane. And we see here this curve showing what kind of wattage this battery can deliver. And at 100% state of charge, it's good for its 1.47 kilowatts. But as your state of charge gets lower, you get less and less power output. And anybody that's rented an electric golf cart has seen this, that feeling by the time you get to the 18th hole that you hammer the gas is just kind of like, and then you can't recreate Jackass the movie at all. Your golf cart's way too slow. Now, what you can do is go boop, 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 and you can drag these around to get whatever response curve you want, depending on how much juice this battery can give you as it discharges. Now, you might be wondering, Austin, why are you looking at this in kilowatts of battery? You know, why don't we use watts? Well, I decided to go for kilowatts because a kilowatt is a little over a horsepower, so it kind of makes sense. But sometimes we get into some airplanes with some serious oomph. I'm now opening the Alea 250, which is an electric eVTOL. Now, the actual watt hours stored on board this airplane are going to change as battery technology evolves, obviously. So, but at a preliminary moment in time, you got 65,000 watt hours in each battery. It's about the same as a Tesla Model S, I think. And 5 batteries. That's a boatload of energy in this thing. And it looks like at the moment that I simulated this airplane, there was some battery chemistry that managed to hold 1,500 kilowatts. Up until about 20% state of charge, and it really plummets. Although, take this with a gigantic bowl of salt, because this is just the discharge rate of the battery that I found for a given chemistry at this particular moment in development of the airplane. But whenever you look at Alea here in X-Plane, this is an aircraft under development. And so all the data that you're seeing me publish here, it's all from a moment in time. And battery technology is improving so rapidly that anything we see here is not going to be the case for long. I'll tell you, battery technology, what it's doing, it's insane. I remember not that long ago that the best electric car you could come up with is the GM Impact, which took like 15 seconds to get up to 60 miles an hour, and it had barely enough range for some people to use. But now, I mean, my Tesla Model 3, it goes like a Ferrari. My wife just got a Lucid Air GT. That thing is 820 horsepower and goes like almost 500 miles on a charge. And so it puts gas-burning cars, it just makes them look like junk by comparison. And so we've seen batteries absolutely leapfrog over gas burning for cars and their performance and range. And of course, you know, the fact that you don't have to go to a gas station, you don't have to wait for them to warm up, you don't have to change the oil. No, yeah, you're not sending money to Russia to bring in gas to turn into pollution. Hello! So batteries have absolutely destroyed reciprocating engines for the car use case. And batteries still don't have the energy density of jet fuel. So they haven't destroyed turbine engines or reciprocating engines in airplanes yet, but the handwriting is on the wall. So electric airplanes are really, really fascinating. If they advance the way electric cars have advanced, there's going to be a real revolution in electric airplanes coming along soon.